and this is h of t is equal to negative 4.9t squared plus 10t plus 70. As I have said, this defines the height at a certain given t, which stands for the time. T is equal to time. Now let us just let us get values for t and get h of t for certain t values 0 to 5. Now if our t is equal to 1, if t is equal to 1, or if it's 0, for example, we have our t here equals 0, then our h of t, or our height, would be equal to 0 or negative 4.9 times 0 squared plus 10 times 0 plus 70, so that would give us 0 plus 0 plus 70. So at 0 we have 70. Let's say these are scales of 10. So we have units of 10 here. We have 10, 20, 30, 40, 50, 60, 70. So if our t is equal to 0, our height would be at 70. Okay, now what happens if our t is equal to 1? So t is 70. If t is equal to 1, then just plug it in. We have negative 4.9 times 1 squared, so that's negative 4.9 plus 10 times 1 plus 70. We will have 70 plus 10, that's 80. 80 minus 4.9, so that would be 75.1. So it's 75.1. So it's somewhere at t equals to 1, so it's somewhere here, 75.1, or approximately 75. Okay, at t is equal to 2 seconds, so this would be at 75, or 75.1, 75, approximately 75. If t is equal to 2, so that would be negative 4.9 times 2 squared plus 10 times 2 plus 70, so that would be negative 4.9 times 4. Negative 4.9 times 4 is equal to 6, 3, 16, 17, 18. So that's negative 18.6. Negative 18.6 plus 20 plus 70, so that's 90 minus 18.6. So that would be 90 minus 18.6. That would be approximately 4, 1, and this is 7, so 71.4. 71.4 and 71.4 for t is equal to 2. So let's have this. This is 1, 2, 3. So 71.4, where's that? It's somewhere near your 70. So as you can see, this graph, if you follow the same progress as I did, if you just plug in the points, or plug in the t values for your expression for your function h of t, this will just go down. Okay, because this is a projectile. It's something that is thrown and then will come down to the ground in a certain time. So the graph should follow a direction which is something like this. Okay, something like that. Now it will be on the ground at this point. So actually we shouldn't have this part already. Okay, so that's the equation. This is the equation. I'm sorry, I erased it. Okay, this is the equation, and this will be the graph of this function, equation, function. Okay, that's it. Now for the velocity, this is defined by somewhat of a linear function, or it will just be determined by a line. So let us take some values for x and y again. So we create a table. Okay, we create a table. We create a table. This would be your x, or in this case it's t actually. T values, and this would be your v of t, or your velocity, or your speed with direction. So let us choose values from t0, because time can be negative. Okay, so from t equals 0, 1, 2, 3, 4. Let's try to find the equation in this given function here for the velocity. Okay, so we have, if t is equal to 0, if your t is equal to 0, then what happens is your v of t is equal to negative 9.8 times 0 plus 10. So your v of t would now be equal to 0 plus 10. That's equal to 10. So we use the value of v of t of 10 taken from this evaluation. Now at t is equal to 1, you plug it in there. You plug it here at t. So that's 9.8. It's 9.8 times 1 plus 10. That would be negative 9.8 plus 1. So that's 0.2. 0.2. Now your t is 2, so that would be negative 9.8 times 2 plus 10. That's negative 9. Negative v of t is equal to negative 19.6 plus 10. So that would be negative 9.6. T is equal to 3, or v of t would be equal to negative 9.8 times 3. Negative 9.8 times 3. Plus 10. So that would be 4, 2, 27, 28, 29, negative 29.4 plus 10. That would be negative 19.4. And let's stop at t is equal to 4. At t is equal to 4, that would be our v of t, or our v of 4 would be equal to negative 9.8 times 4, negative 9.8 times 4, 2, 3, 36, 7, 39, so 39.2, negative 39.2 plus 10, we have negative 29.2. So putting all these values here, negative 9.6, negative 19.4, and negative 29.2. Now we use the grapher to graph this. We have our virtual grapher here, and let's use them. So let's use the values, and let's use our coordinates. So it's something like here. Okay, now this is our t values, and this would be our y values, or v of t values. Okay, since our v of t values are pretty large, we could make units of 5, for example. 5, 10, 15, negative 5, negative 10, negative 15, negative 20, negative 25, etc., etc. So this is our t. This is 1, 2, 3, 4. T, and this is our v of t. So if our t is equal to 0, we have 10, 0 and 10, so it's somewhere here. If we have 1, it's 0.2, so it's closer to 1. Okay, now if we have 2, we have negative 9.6, so now it's negative. It's closer to 10. If we have 3, that's negative 19.4, so it's closer to 20. And if we have 4, it's 29.2, so we have closer to this line here. Okay, so now we take out the grapher and we connect all of the points. So this is a projectile or a curve. It's not a line. I'm sorry. This is a line. This is a line. It's a straight line. Okay. To make it look like a straight line, it's more accurate. Okay, if we use this. Okay. So as you notice, this is going into direction downwards. It's going downwards. Okay, it's going downwards in a direction which is negative for y and positive for x, or in this case positive for t and negative for our v of t. So let us highlight this this graph here, or this line here. So it would go something like that. Okay, now this is the end of our lecture for the terminology of f of x, and thank you for listening and watching.